Ariano Family 82459 Deborah Dr. Indio California 92201. I wish I could say this would be the last time I would write, but I know it's not. Let me start off by saying hello, my name is Anthony Ariano. I think you may be familiar with my research. Well, let's jump in. The 3 generators in Sonic Health Attacks. I'm sure you are all aware by now that these 3 generators working together do great things in the right hands, but my family have fallen prey to domestic terrorists. This weapon can do many things: nonlinear audio and video surveillance, quantum optics, DW, directional energy weapon, superposition beat frequency, microwave auditory effect hearing, and many more. I have come to the end of my road and found out all I need to know about this device. Here are the schematics for GPS, rubidium, frequency comb generator, phase lock loop, and satellite schematics. WHQT I think is odd as they are basically the same, but I know for fact the loop lock we are being tortured with has quantum optics, which means it can see into a person's home, nonlinear things that make you go hum. So today I thought I would just finalize a few things, and I found something out: the schematics that I downloaded for a GPS, rubidium, frequency comb, phase lock loop. The same things used in our satellite signals. Do your homework on how these 3 generators work, people.
One of the basic circuits that you use in advanced digital and analog design, and I'm going to be using, for a specific example, the CD4046, which is part of the original 4000 CMOS series, which is a real standard Jelly Bean set of logic, much like the 7400 series, which most people will often see in many projects. The phase lock loop consists of 3 parts. You have the phase detector, the low pass filter, and the voltage controlled oscillator. The voltage controlled oscillator is probably the easiest to understand.
This is a frequency comb generator. So this is attached to the GPS generator and the rubidium atomic clock generator. This is the one that actually locks the loop around the target, and everything inside gets filled with rubidium atoms.
You put in a DC voltage and it puts out some frequency. You raise the voltage, the frequency goes up. You lower the voltage, the frequency goes down. I'll demonstrate that live for you in a moment. What the voltage controlled oscillator does is you feed that back into the phase detector. What the phase detector does is it compares the voltage controlled oscillator to a different input frequency. So the input frequency would be some sort of analog signal or something you need to recover, or some sort of RF transmission, and it would compare these.
RF transmission being the GPS transmission, that would be the RF.
It would look at the frequency coming in, and it would look at the frequency from the VCO, and it would make some sort of judgment as to whether these 2 signals were in phase, or if one was a higher frequency than another, and it would produce an error signal. So, like, if the VCO frequency was too low, or it was behind in phase, the phase detector would produce a positive error voltage. If the VCO was too high or ahead, it would produce a low error voltage. This would be fed into a low-pass filter. A low-pass filter is a filter that only passes low frequencies. So it's like in music, if you were to put standard music through a low-pass filter, you would only hear the bass and the low, deep stuff. We're using this as kind of a long-term average. We're going to look at the error signals coming out over the last few cycles, and then use that to make a judgment.
Now keep in mind, these are all going to be microwave frequencies, so anything that's ingested through the GPS generator with the L1 and the L2, depending on if they're military or not, if those are put together with the binary phase shift key method, then that can be put in there, and that's going to go in through all of this. It's going to be combined with every single one of these things. So if they put an extra frequency in there, which will explain there that you can put extra frequencies in there, that will be part of the loop. If they want to connect to that loop outside, they can use an SDR to dial that frequency in, and they can use that for microwave auditory effect hearing and make you think you're hearing voices. So I know, great tool, isn't it? The reason why you can hear the radio frequencies is because everything inside of that loop is a microwave. It's basically microwave frequencies, and then when you're exposed to it for a long enough period of time, You get microwave auditory effect hearing. All of these things. Look them up. They're there.
On whether the control voltages we're sending to the VCO is too high or too low. Because if we get a lot of positive error signals coming from the phase detector, then our control voltage is probably too low. And so the average will eventually slowly trend up and the VCO will lock on frequency. When we say lock, that means that when you first start it, this is going to be some random value. You're going to start feeding in some random frequency, and the loop is going to have all sorts of errors because it's like, whoa, like these are completely different frequencies. All right, and eventually the VCO is going to be like wandering all over the place. And eventually, once this frequency, the frequency in and the frequency out, or I guess the frequency out going back into the phase detector, once those are the same, the loop will be locked. And once it becomes locked, it'll be much more stable, and it'll be able to track the input frequency if it drifts or anything very closely. All right, now, you kind of have to ask, what is this useful for? The really simple example is you could use it as a frequency multiplier. So if you were in this feedback part of the loop to put in some sort of divide by n counter, so like the simplest would be a divide by 2, what you would do is this frequency would be divided by 2 and then compared to the input frequency. So if we feed it in like 1 kilohertz here, we would get some sort of error signal. It would be filtered, and then the voltage-controlled oscillator would start making some frequency, but that frequency would be divided by 2. And so if the voltage-controlled oscillator was also running at 1 kilohertz, it would be divided by 2, and you end up with 500 hertz here, which would be too low. And so the phase detector would create a positive error voltage. It would get filtered. The VCO would slowly drift up to 2 kilohertz. 2 kilohertz out, but it's divided by 2, so it would go back and it would be 1 kilohertz here. And so we'd be comparing 1 kilohertz with 1 kilohertz. This would say, hey, these are in phase and locked. It would be slowly filtered, and the VCO would be very stably running at 2 kilohertz. This obviously has other applications. Multiplying one. So that was the low-pass filter part here. I just implemented it with some passive resistors and capacitors, but obviously you could use op-amps and gyrators, and you could over-design the most sophisticated low-pass filter that you could ever want to be as part of this control loop. I've taken several mechanical engineering classes in control loop theory, but they weren't so practical or applied, so I fully diswarrant any claims that I made here as far as actually getting any of the technical applied details of that correct, because I inevitably probably did not. And so it's kind of one final last thing. We're going to slow this filter down way slow. So where this is a 10 microfarad, we're going to take this, I believe it's 1,000. I believe this is so this is 1,000 microfarad. So we're going to slow this filter down 100 times, and we're going to start it grounded. And so the VCO is essentially stopped because the output is, the capacitor is completely discharged. And so as it slowly, ever so slowly, is going to pick up here, hopefully. Yeah, so you can see it got its first transition. And so as you can see, the output is slowly, ever so slowly, increasing. And obviously this is obscenely slow. I mean, this is like a 100-second time constant filter. So you would never actually design a phase lock loop with a 100-second filter on it. But this will very well demonstrate.
Workers in Havana who were hearing these unexplained sounds in their residences and later developed physical symptoms. Americans who heard these sounds in Havana have described slightly different sounds, and even in some of the recordings